Yeah, so we are just going live from the studio now, and we are live. Is it live? Yeah, so we are live. So, good afternoon, everyone. I welcome you all to this pre hackathon workshop, which is Build with Algorand, and we have Mr. Pranjal Bharadwaj with us. Pranjal has done tremendous research in the field of blockchain and AI, and he is currently Dev-Rel APEC at Algorand, and he will guide us through a deep dive into Algorand in this stream. And also, meanwhile, just a quick announcement that during the workshop, if you have any doubts, please feel free to put them in the chats, and Pranjal will pick them up. So, Pranjal, the stream is all yours. Yes. Meanwhile, the stream is loading. So, like just everyone, like, how are you guys feeling? You can just put that in chat, like if you are excited for this workshop or how's it going, so that even we can verify that the stream is live and everything's working fine. Yeah. तो क्या करना पड़ेगा? Uh, actually, Pranjal, sorry to cut you off. Actually, I guess there's some issue with the software. This on your voice is not going to the stream, so let us just quickly refactor that once. Really sorry for the disturbance. Yeah. So uh, Pranjal, can you try once now? Like,
Yeah, I'm audible. You can maybe like I think
yeah,
we'll have
yeah,
to
I'm
wait
just
for it.
verifying with the team.
Yeah.
Yeah, I guess yeah, it's working now. Sorry for the delay.
Okay.
Sorry for keeping you waiting, everyone. So yeah, Pranjal,
Okay.
the
Yeah.
stage is all yours.
Yeah. I think we can get started now. So I was just saying that this session is called Build with Algorand, so that you guys can get familiar with Algorand and what this technology is. You know what blockchain is, and then you can get started with building different apps, and you can make some cool projects during the hackathon. So yeah, so this session is mainly about that. As Tanmay has already introduced me, I'm Pranjal. I'm doing developer relations for APAC or Asia at Algorand Foundation. So our mission is to help developers as much as possible, and specifically my role is to make sure that developers are happy building, especially in the Asia Pacific region. So let's start with what is Algorand, so that any of the folks who are new to this word, this whole technology, they will understand what this is about. So Algorand is a layer one blockchain. If you guys don't know about layer one or layer two, I think if I go in more details about what is layer one, what is layer two, or what is sidechain, I think it's going to take a lot of time. But maybe you can do that research yourself. But Algorand is considered as a layer one blockchain, which is not EVM compatible. And just to give you more, history about it, it was founded by Sylvia McCallie, who is a Turing Award winner and who is a Turing Award winner uh, researcher. He's a professor at MIT, and he's also a well-known
सुन
cryptographer.
चैट को ही देखते रहो
Silvio has
टाइम.
done some uh, great like research within the cryptography space and stuff like ZK. uh, zk rollups, and the whole idea about vrfs, which is verifiable random functions, which is like kind of like core concept of Algorand, has been founded by him.
Parking a
And
video.
that's why he was awarded with Turing Award, which is I think the highest level of honor in terms of computer
नहीं
science
सामने
degrees.
होता नहीं
So
मत छेड़ वो जितना छेड़ रही है
I mean, he's a really great researcher, and he founded Algorand. And as I said, right, so what distinguishes Algorand with other layer ones
अरे तो बोल
like
मैं दोनों
Ethereum or
रिकॉर्ड करता
Solana is the consensus mechanism, which is
अरे तो फिर वो
like a
क्या
very
करता हूँ
unique way of how
ये
a
दोनों
blockchain is reaching consensus. And what we use is something called as a pure proof of stake. It is different from a traditional proof of stake that Ethereum has, or or some of the other EVM compatible layer ones might be having. As we know, Bitcoin traditionally has proof of stake. Uh, they have, sorry, as I said, so Ethereum has recently uh, transitioned into proof of stake from proof of work, which is also what Bitcoin was using till now, which is not very, I would say, which is not very optimal. So pure proof of stake is an attempt in that direction to make a optimal and come up with an optimal consensus mechanism. Now, that of course makes Algorand highly efficient and scalable, so that we can reach finality in a transaction, uh, very instantaneously. And what finality means is that if you're sending a transaction, whenever we send money to someone through UPI, or whenever we make any sort of transaction between two people, the amount of time that you take to kind of verify that okay, this transaction has been completed, that is called the finality of the transaction. So this makes Algorand highly efficient and scalable, and the transaction time is almost instantaneous. So it makes it really fast to use. And of course, Algo is the native coin of Algorand blockchain, which is used for paying fees, paying rewards, all of these different things within the Algorand ecosystem. As I said, so ecosystem, Algorand ecosystem is very flourishing, and it's increasing since the day we have gone live. Just to present some facts to you, in the last year, we have grown, like it has been 900 new decentralized applications, which has been published to mainnet. We have had 13 million new wallets created to transact any assets, or just currencies through Algorand. And we have also had three mainstream games which were launched on mainnet. So the ecosystem is continuously growing. Of course, some of these numbers are a bit older, but we are constantly making different partnerships. We are constantly making different tie-ups with universities as well. We have a wonderful initiative called Algorand Blockchain Clubs, which is like where we fund the research for blockchain in different universities. And in India, we have tie-ups with some of the IITs to further the research of Algorand, and specifically blockchain. So yeah, so in general, last year we have had 17,000 new developers who have come in, and they have started building something. So of course, the ecosystem is going to be constantly increasing from here. Uh, Here I want to just showcase one of the use cases which was recently, it gained a lot of traction recently, and I think this is worth addressing. It's called Hisab Pay, and this is one of the articles that we had on our website as well, which covers the entire breakdown of what it does, and what it is about. But of course, the live stream, sorry, the mainstream media has also covered it pretty well. So just to give you just about Hisab Pay issues digital Afghani, which is the Afghan fiat currency, and it is based on the fiat deposits, and it settles transactions on the Algorand blockchain. So whatever transactions are happening between the fiat Afghan currency, it is done through Algorand blockchain. And in order to this is done in order to bridge the financial exclusion gap in Afghanistan, so that anyone can send and spend their digital Afghan through their phone, which just has a wallet, or they have an account. So users can make digital payments. They can shop with different merchants. They can pay their bills. They can do anything they want with the Hisab Pay. And they have also integrated something called as on ramp and off ramp solutions just to convert these different currencies, and so that they can use the fiat and digital economy. So this is again a very interesting use case, and just like Paytm, they've also integrated a facility of using QRs to make the payment possible. So so the merchant can just scan the QR and they can request for the payment from a customer's account, and they can just make the transaction happen. And as I said, the transaction finality is really less, so the transactions are immediately settled, and you get all the benefits of building on Algorand. Another use case that I want to discuss is called Agro Token. So Agro Token is a global agricultural commodity tokenization platform. They created agro tokens for different agricultural commodities like soya, corn, and wheat, and they basically collateralize these crypto assets uh, for saving and exchanging these assets. And AgroToken recently also announced a partnership with Visa to further co-create the payment methods, which enables agricultural producers to use their grains uh, in form of these tokens, and they can just transact through it. And Algorand blockchain is making it possible because we provide them with fast, secure, and highly scalable solution, which also consumes very low energy. And it is focused on building something sustainable in the longer run. So in order to minimize the environmental impact, this is an approach which was used by AgroToken. This particular project has also been uh, acknowledged by the government of Argentina, and this has been one of the biggest use cases that we have had in the last year on Algorand. So let's move forward. Yeah, so let's move forward with what are the key characteristics of Algorand? What makes it different from other layer ones, and what is the basic difference of using Algorand, as compared to some other chain, and why are we going to be using it? What basically makes Algorand stand out? So when we talk about different features, I think we can basically kind of compare chains on these main five features. First one is about speeds. Like, what is the block time to kind of make sure the finality happens? As I said, finality is the time in which we know that transaction has gone through or not. So that whenever if I'm developing something, if I'm sending test transactions, I don't have to wait around to make sure that the transaction has gone through, and then I can build further. It really helps developers. It really helps payment aggregators to make sure the whole process happens within seconds. And for us, it has been 3.7 seconds. If you look at some other chains like Bitcoin and Ethereum, you will have to wait around for like 10-15 minutes to make sure that your transaction has happened. But with us, it has been only a matter of 3.7 seconds. This is like the most recent number that we have had, and we are happy to kind of reach this level. It was, I think, 4.5 seconds last to last year, but yeah, since last year we have had 3.7 seconds as our best block time. Now, coming to the scalability, I think a TPS is a very good measure of scalability, because transactions per second can really tell you a lot about how much throughput is possible through a particular blockchain. And with us, very recently we have seen that we have had almost 15,000 transactions per second happening on our chain. This number was only about 1,000 transactions per second, only 1,000 TPS in the beginning of last year, and then we reached to 6,000 transactions in the middle of the year. And recently we saw that there were some spikes in the Algorand network, and we kind of stress tested it to see how much it can, uh, how much it can handle, and it was about 14,000 TPS, which is again, it gives a ton of room for us to scale. Now, coming to the factor of cheap, so it is extremely cheap to use Algorand network to send transactions. Even if you are making a simple withdrawal or you are making different transactions, it costs you a fees of about 0.01 algo, which is a very minimal account, because it's gonna be like I think thousandth part of a cent. of a dollar. So it's not gonna hurt you while every time you're sending a transaction. While in other layer ones, we have seen the gas fees have gone through the roof whenever you are making a lot of transactions. When people are really active in the network, the networks get congested and the gas fees goes through the roof, which is not the case with us. So again, it is a huge benefit for anyone to use Algorand. Now, coming to the stability, how much can a developer or just anyone who is interacting with the chain can trust the network. And I think stability is very important. Like we have seen some of the biggest layer ones, just shut down the network for a while, or the network went down for hours, and the developers can't really do anything. They have like, they might have different exchanges, they might have different projects running on the chain, and then they don't have anywhere to go because the main blockchain is down. But we are happy to say that we have had no downtime since we have launched. So since 2018 we have had zero downtime. We have had, none of the blocks have failed since then. And yeah, even on testnet, on mainnet, this has been very consistent. And this is also included with the stress test that we have done, so that we have really taken the network through extreme conditions, and still it has been able to stay alive without any sort of downtime. Lastly, about decentralization, it is very important for a blockchain to be decentralized, because uh, you don't want a monopoly of one person or few people to kind of gain access to most of the network, and so that they can turn things around, and maybe they can switch things in their favor. So we really encourage decentralization, and we at this point we have about 3,000 nodes participating in consensus. And we'll be talking about more in this in the coming slides. What kind of nodes are there who are participating in the consensus and what makes it unique. So yeah, so coming to the network, as I said, we have different nodes who are participating in consensus. Mainly, we have three type of nodes. There is participation nodes, there is archival nodes, and there is relay nodes. So participation nodes are used for block proposals. These nodes participate in consensus. These nodes are the one that have any account linked with the participation key, and they verify the state of the blockchain. And these nodes should be as much as possible in a blockchain to kind of maintain the decentralization part of it, as I said in the last slide. So that is about the participation nodes. Coming to archival ones, they store entire blockchain so that you can also run indexers on it. Indexer is basically like an API to query the entire blockchain and find out certain data points on the blockchain at a particular given time. So participation nodes only contain the data or the history of last 1,000 blocks, but archival nodes will contain the data about data of the entire blockchain. So archival nodes are used to whenever we are doing whenever we talk about high frequency traders, or someone who needs historical data, they would be analyzing data not just last 1,000 blocks. They'll be analyzing data since the entirety of the blockchain. So they will be using something called as archival nodes in that case. Lastly, we have the relay nodes, and which are used for efficient communication between the participation nodes. So relay nodes at this point are currently hard coded into the software to connect with the network, and end users can specify their own relays. It basically routes data between different nodes, and we have made it a very small network of trusted relays, so that the network is never hacked, and there is that kind of uh, trust in the system. And let's see, if we expand it in the future. But so far, we have good amount of participation nodes taking part in decentralization. Now, coming to the layer one characteristics, right? So, what are the things which are different on Algorand, right? What are the things that stand out? Of course, the main thing to note here is that Algorand is not EVM compatible, so we don't use Ethereum virtual machines to convert the smart contracts into bytecode and then run it into EVMs. We have a virtual machine of our own, which is called AVM, Algorand Virtual Machines, and it really changes a lot of things. It is by choice, so that we can have more flexibility, we can have better specs in terms of like so that we can increase the scalability more, we can have more security on the blockchain. Now when we talk about layer one characteristics, there is a bunch of them. Firstly is it's called ASA, or you can say Algorand standard assets. Now ASA, or you can say a standard asset, is just like a simple asset which is on another chain, can be fungible or non-fungible. So we have fungible assets, and we also have non-fungible assets, or we also call them as NFTs. uh, on any other blockchain, which is like smart contract based platform, you will have NFTs which are implemented as a standardized smart contract, right? So you will have to write smart contract to kind of execute the NFTs. But on Algorand, it's a native asset, so it's like having an NFT or having a fungible token is like transacting like a token. It's not a smart contract, so you can expect the same kind of flexibility with it, but you can also expect the same level of security during the ASA transfers that you get while using ASAs. Coming to atomic transactions, so atomic transaction is a way, it offers a very secure way to simultaneously transfer a number of assets amongst different parties, and it can group up to 16 transactions at a time and then kind of distribute it at the same time. It can issue up to about a total of 256 inner transactions, which are used to call during the smart contracts. So net net, it just bundles a bunch of transactions, and it can be used to simultaneously transfer assets among different people with just one call for this particular for this particular transfer. Now next would be rekeying. Sorry. Yeah. So next will be rekeying. Rekeying is a feature of Algorand which solves for the particular uh, existing public address and the private spending key friction by allowing users to change their private spending key without the need to change their public addresses. So whenever we create an account, we always have a public key and a private key. But if you want to change the private key, you'll have to create a new account, or you'll have a new public key as well, right? But on Algorand, it's a feature that you can rekey the account. That means that you can have a new private key without having to change the public key. So again, it's a great feature to have. Then we have smart contracts. Of course, you can write smart contracts, and there are mainly two type of smart contracts. There are stateless smart contracts and stateful smart contracts. Stateless smart contracts are used to approve spending or asset transfers, and they govern all the transactions from a specific amount. Now, stateful smart contracts implement application logic. They can store and update on-chain values. They are, both of these are not even compatible. As I said, they work on AVMs, which is Algorand virtual machines. Lastly, we have state proofs, which is one of the newest features of Algorand, which was launched last year. And basically, what state proof helps us in doing is it allows Algorand to export the state of the chain to other blockchains. So it is extremely useful to have multi-chain interoperability, so that you can just export the current state of the chain to other blockchains, and then they can use it to verify transactions, or they can do whatever they want with it. And this actually brings stuff like bridges and bridging between different chains, and bringing assets between different chains very easy. It also makes Algorand more secure, and it ensures post-quantum security, which is one of the biggest topics when we talk about quantum computers and blockchain in the similar view. So we also get post-quantum security of a kind with the help of state proofs. So, coming to Sandbox, Sandbox is something that we'll be using a lot to interact with the blockchain. Sandbox is a very good tool because it creates private network for you, that gives you a very consistent environment to test your dApps or test your smart contracts or logics, whatever it is. um, because whenever you are trying to work on a blockchain, let's say in a beta net or a test net, the environment can be a little bit inconsistent, but you can get a consistent environment with the help of sandbox, as it creates a private network for you. Again, it is the quickest way to spin up a test node, and then you can have a indexer on it. Of course, you can't have an indexer if it has a test net, but you can have an indexer if it's a private network. And another great thing about Sandbox is that you get pre-funded accounts, and you don't have to go to the dispenser and request for funds again and again. You get pre-funded accounts. You just have to spin up the Sandbox, and it already creates account for you to kind of test and do all of these things very easily. So it basically has four main components. First is Algo D, which is a network node. Then we have Goal, which is a transaction builder. Then we have KMD, which is a key manager, and then we have Indexer, which is a query tool to kind of query data on the chain. And as I said, we have sample commands, we have funded accounts, and we don't have to go through another extra step to kind of do something. So uh, uh, I'll be talking about how you can set up your dev environment, how you can get started with building on Algorand, and these are the main steps that you have to follow. So let's go over them. Firstly, you'll have to make sure that you have Brew installed. If you're working on Mac, Brew is very useful because whatever things you want to install next, which is Docker or even Sandbox or Python, whatever it is, you can easily install it with the help of Brew. If you're building on Windows, then there is one extra step that you have to follow. You'll have to use WSL to connect to the Algorand sandbox. So that will be another extra step that you'll have to look up. But in this video, I'm going to be talking about just how you can set up the environment on Mac. So you'll have to have Brew. You'll have to have Python 3.10 or above version to use Sandbox. You'll need to install Node.js, and then we can go on to install Sandbox. We can change the configurations, and then I'll show you how you can initialize it. Um, I'm assuming you already have Docker installed, but of course, some of the people here might not have Docker installed, so you'll also need to install Docker Compose to work with it. Let's see if we can uh, go and see the setup for all of this. So I'll just share my screen now to show you guys how it looks. Okay, so this is the repository that we have. Uh, yeah, I hope it's visible. Yeah. So this is the repository that we have for Sandbox, and it has uh, it tells you how to set it up. So if you want to set it up on your own, there's not going to be a problem with it. And all you have to do is clone this repository. So there's a command for given over here, or you can just go above and you can copy the path over here. So yeah, so just clone it, and then you can open up a new terminal, and then yeah, and then once this is about installing Sandbox. Once you have all the predetermined things installed, which is Python, Node.js, you have Docker, all of these things installed. So once that is done, you can just simply let me actually just change the directory. So let me just say if I want to install on desktop, how it will look like. So I'll just change the directory to desktop, and then I will just clone it. So it will create the folder for me. Sandbox will be created, and then I can go inside of this folder. I will go to Sandbox, and then the way I will be initializing it is a very simple command. You can just do dot slash sandbox up. This is a very simple command. So, but you have to make sure that your Docker is running. So I have my Docker over here running. Of course, I have a test net running in the background, so it's saying that all the three containers are running. But when you'll be doing it, it will be saying that there will be no containers over here running. So yeah, so once you hit enter, it's gonna automatically execute. I will just show you how it happens because I did it previously, so that I don't have to repeat it again and again. So yeah, this is the thing that I executed. Sandbox up dash v to get more details of what we are doing. So it installs the algo d versions. We have the indexer version and we have the Postgres version, and then it spins up the node for us. And this is the main output that we're looking at, which is the account list. So these are the pre-funded accounts that I was talking about that it creates for us to use. So these accounts are created automatically for us to use, which are pre-funded with this many algos, so that we can directly use it to make transactions, within apps. So we have, these three accounts created for us, and then it also tells us if I want to like kind of check if these accounts are working, if they're real or not. I can kind of execute this sample transaction to see if this will send some specific amount of micro algos from one account to another. Pre-funded. So that's how you can spin it up. And if you want to switch off the sandbox environment, you can just say sandbox down, and it will stop the containers from running. And you can also check in the and in the Docker that it will stop. What I have over here is the testnet version of it. So if you do sandbox up testnet, then it's going to run a test network for you. It's not going to be a private network. It's going to be a testnet node. You will not have indexer. As you can see, indexer is disabled for this configuration, but you will have the algo D node, and you won't have the pre-funded accounts. Fund the account. So this is a step which gets started when we kind of work with testnet, but of course we'll be testing a lot of apps in testnet before pushing them to mainnet. So this is also a necessary step. So yeah, coming back to the slides, let's see what we have next. Yeah, so that was about Sandbox. Now I will just talk about the SDKs that we have, which are used to interact with the blockchain. So we have the official version of SDKs, which is available for JavaScript. We have Go, we have Python, and we have Java SDKs. And the link for that is also I've added here. If you want to like explore documentations of these SDKs, you're more than welcome to kind of do that. We also have the community SDKs, which folks from the community have kind of contributed to make it. So we have community SDKs of Dart, PHP, Rust, Swift, Unity, and .NET. Of course, the community support is always going to be much better on the official SDKs, but you're like kind of free to use whatever you want. Now, I'm gonna be doing a small demo of the SDKs, how you can send your first transaction on Algorand blockchain, how you can make that happen, and it basically involves this sequence of step to make that happen. So we'll need to install the Python SDK. We'll need to create an account because that does not come automatically done with the testnet version of Sandbox. So we'll need to create an account. We'll need to fund the account, and then we'll connect with the client. We'll check the balance. We'll build the transaction. We will sign the transaction, and we will submit the transaction, and we'll see the changes if it actually works or not. So let's do that. I will just stop sharing and open VS Code. So I already have the testnet sandbox running. Yeah, so this is the This is the VS Code. And for any of you who wants to follow this tutorial, they can also go on our website, because this is kind of explained very nicely in the documentation, your first transaction, and you have different SDK options available. What I'm going to show you is the Python SDK, but you can replicate this with any of the SDKs you want. So as I said, right, so you'll need to have the testnet version of Sandbox up and running, and you'll need to install the SDK library for Python, which is PyAlgorand SDK, that you'll have to pip install within the particular environment that you're running in. Now, I basically have created two different files over here. I have the getting started file, which basically uses the Algo SDK to create account for me, and then I'm going to just print the account address, private key, and the passphrase that I have, which is a mnemonic, so that I can use that account and then come to the first transaction script and I can make that happen. So if I were to execute this, Python getting started.py, it gives me a new account. It creates a new account for me. So it gives me an address, it gives me a private key, and it gives me a passphrase, which is like a mnemonic that we have 24 words mnemonic. So I'm going to save this information because this is important for us to use. And I'll be coming back to the transaction one. So what we need to do is, okay, let's first see what the transaction file is doing. So it had the generate part of it, which I've already migrated to the second one. So let's see this one, what's happening. So it takes in the private key and the address. It has predefined algod address and the token specified. It prints the current address, it prints the account balance, whatever micro algos that can be, and then it builds a transaction for us. you know this is the burner account that we have to kind of send the test algos, and then we have the unsigned transaction with all these parameters. Then we sign the transaction, and then we finally submit it to the algod client to execute it. And then we just print out the information about it. What was the transaction ID, what was the transaction information. We have the final account balance after the transaction has been done. So all of these things we can kind of get it. So what are the things we need to do? We need to fund the account. We need to create the account, but we already created the account. We have this account. Now the next step is to fund this account. To fund this account, I will just copy the account address, and I'll go back to the dispenser that we have. So you can you can go to this link, and you can claim some test algos to you know uh, test your apps in testnet. So I'll just do the verification, and I will enter my Algorand account, and I will click on dispense, and it's going to send some test algos in my account. And meanwhile, what I'll do is, as I said, right, it will be taking two parameters. It will be taking my private key and the address. So I already have the address copied here. So I will just, this is where we are referencing these. So I will just add the address, and I will also copy my private key, and to make the transaction happen, I'll paste the key here. Okay, I will save the file, and I'll see if the dispenser worked. Yes, so it has dispensed. It has given me a transaction ID. So they have dispensed some test algo for us. Now go ahead and run this one. First transaction.py. Okay, so it printed the account address. It printed the account balance, which we kind of claimed, and there we have it. We have successfully initiated our first transaction with the help of Python SDKs. We have we had the note as hello world. It has it. We have the starting amount of we have the starting account balance, which was 5 algo, or you can say 5,000 micro algos. Then we have amount transferred that we specified, then the fees for that, and then what was the final account balance. We also have the output for that. So this shows us that we were successfully able to make the transaction happen. And we have all of this information. We also have the transaction ID, so I can just copy that, and I can just like we have Etherscan, we also have AlgoScan. We also have our own explorers where we can just paste this ID and we can see what was the transaction about, what were the accounts involved in the transaction, how it happened, all of that. So transaction has happened, right? So this was a small demo of making sure that your first transaction go through on Algorand. Now coming back to the presentation, I'll just share my screen again. I'll go more in detail about smart contracts. What smart contract is? Smart contract is a smart code which is written on a blockchain to automate all of these things. It's like a logic that we write. Uh, uh, like we have backend logic for our application. That's same for blockchain. On blockchain, we have a smart contract executing these logics automatically for us. So we write these smart contracts, we deploy them on the blockchain, and it kind of executes it as soon as the logic is confirmed. So these are small programs which lives on chain, and they will interact and they will execute on their own. That is a smart contract. And what are the examples of a smart contract? It can be anything from a DeFi app, like an exchange, like a decentralized finance app, or that you might be using for exchange or lending or any of the other DeFi related things. You can create a crowdfunding app. You can create a voting app. You can have a decentralized name services like we have, algo domains. We have NFT domains. We have ENS domains for Ethereum, and we can also create like a lottery system. And these are like different use cases of logics that we can write and make all of these different things happen. uh, okay, so now coming to what a smart contract can do, it can read and write data, or you can also say state of the blockchain. So for example, any of these apps, it can read and write the data for that. It can receive tokens from another account, so you can automate the process of making transactions happen through the smart contract. You can send tokens account to another account. You can also automate that whole process, and and a smart contract can also integrate with other smart contracts. For example, taking a result of a vote and then executing a logic on its own, or taking on-chain prices from Oracle or some other decentralized resources, and then using it for the with a smart contract. So a smart contract can also integrate, uh, can also interact with another smart contract. Now, what a smart contract cannot do, uh, it cannot communicate with the outside world or any other blockchain. Like it is specific to a particular blockchain. As I said, right, Algorand smart contracts are specific to Algorand, and you can't really interact with smart contracts or the blockchain which is outside of Algorand. So it cannot directly access any website or other information or data points for you, like weather, price of different forex currencies. It's not going to do that for you. We have but we do have different oracles or bridge which allow this information to transfer. As I said, right, but the state proofs that we are working on, it's going to help in getting information from Algorand. Let's say if I'm sitting on Ethereum, I can get some information from Algorand and I can use it as I want. But traditionally, it won't be possible with a smart contract if we don't have any bridges or oracles or anything in between to kind of work with. Okay, so let's move forward. How do you interact with the smart contract? You basically deploy it on the blockchain, and what you have to do is uh, you have application transactions which kind of like the transaction that we just did. It will kind of ping the blockchain to make the transaction happen, or whatever further things we want to do. So You can integrate with a particular blockchain with the help of smart contracts, or you can use SDKs as I just used. So it's just different ways of interacting with the blockchain. So coming to the storage types and the transaction types on Algorand, we have firstly, let's understand what are accounts and smart contracts in detail. So accounts are also known as wallets. So every time you kind of create a new wallet, it's kind of like a new account. You'll always have a public key and a private key. Public key is the key that is visible for everyone, which you'll also like kind of share with others to send you funds or to request funds. But a private key is something which you should not be sharing. As I showed you in the tutorial, like um, I shared my private key with all of you guys. You shouldn't be doing that if you are holding some funds within an account. And to make it easier for kind of like for us to like understand this, we use different word mnemonics to which can be used in place of uh, private key to make the whole process easier for folks who are new to the blockchain and Web3 space. And we have smart contracts, which, as I said, which are applications living. These are the programs which live on the chain, and we have accounts which can send transactions to deploy, call, update, delete, and do all the different things within an app. So, with the help of application ID, you can kind of execute whatever different things you want. Coming to the explorer that I said, right? So if we have explorers where you can just paste an account address to see how many funds they are holding, or you can use a transaction ID to see when the transaction happened, how long did it take, what was the amount which was transferred. So we have something called as Algo Explorer to algoexplorer.io to see all of this. So this is like a screenshot of what is included in the Algo Explorer. We have address of the account, we have balances, what are the different currencies it is holding. We have transactions of the account, all the recent transaction that it did. We also have the application call transaction, or like it can be different, right? So you can see in this particular example, the top of the line of these transactions, the first one is the application call transaction, because the type of the transaction is app call. And when it says transfer, it's like a normal transfer of a certain amount of algo or USDC or any other assets on Algorand. So this is about the Algo Explorer, and yeah, as you can see, this is particular to an application. The previous one was for particular to an account. Whenever we have different apps deployed, then you also get a app ID, and whenever you paste an app ID, you can see all the information about it. So yeah, so it makes it very simple for us to kind of get access to this information. Now, now discussing what is the difference between a full blockchain versus state of a blockchain, because we'll be going into detail about what the different states on a blockchain. We have two different states, global, local, but what exactly is a state? A full blockchain is basically a list of all the blocks. It will have information of all the data and all the different things of the ledger, since its entirety. But when we talk about state of a blockchain, it's a smaller database of recent transactions, or it can be like special transactions which are recorded in a particular period of time. And why it is used is because the full blockchain data can be a lot. As I said, as I've kind of referenced here, is till February 2022. The data which was used in Algorand was about 996 GB, but at Ethereum it was about 11 TB. So this data is constantly increasing, and whenever you're spinning up a node, you're kind of like accessing and making sure this information or this data is copied on your node. So it is a lot of data. So rather than using the entire blockchain, we use state of a blockchain, which is like a database stored in each node. And we reference the state of the chain at different places to kind of work around with blockchain. Now coming to effect of a transaction, it just this is a okay. So whenever we are making a transaction happen, the state just updates. So while on blockchain, we would be storing the information through each and every transactions. In smaller transactions, the state of the blockchain will not increase substantially in size. When we talk about data, so this particular transaction will not really create a lot of load on the state of the blockchain. State is defined by the Genesis block, where when it is fully synced, current state of the node is the state of the blockchain. So a current state would be the particular state of the blockchain at that particular time. Uh, Now coming to the global state, so smart contracts can read write data and also access the state of the blockchain, as we previously talked about. But applications can be stored in local state or global state. We have two different states. Now, global state, you can understand it as a database of up to 64 key values. Each key value is 128 bytes at most. What it means is, for example, I think I have some tables. Yeah. So in this particular example, do you have? Yeah. So in this particular example, as you can see, we have this table on the right hand side, which basically defines an application ID. And for this particular application, we have different keys and values. So it's like a key value pair, but the number of key value pairs are restricted in a global in the global state. It is restricted to up to 64 key value pairs. But let's say we are doing a voting kind of a scenario. We might have more people voting in than 64. We will have to record which person is voting yes and which person is voting no. So in that case, we use something called as local state, which runs one instance for every account that is opted in. So this is opt-in is again a unique feature of Algorand. To make a to make a transaction happen, an account has to give explicit permission to make sure that happens. This is done to kind of secure the accounts from unnecessary spamming of different assets. Of like we see Vitalik often gets spammed with different tokens in his account. Unless he's opted in a particular asset, he won't be able to receive it. So this is a very cool feature that we have. And once an account is opted in, it runs one instance for every account that is opted in. So it means that it's a special transaction that it can happen in ASAs, it can happen in different things, but it can basically what it basically means is, as I was giving an example of voting, we can have a registered voter and we can have a value of yes and no as ones and zeros. And if it's a registered voter, we'll of course have a value of one, and then we can also record the value of votes as yes or no's, and it's going to give us more room, more than just 64 key values to work with it. So yeah, so coming to teal, we have gone through smart contracts. Now coming to, how do we like kind of interact with the smart contract, what languages do we use to write the smart contracts in. And Algorand uses something called as teal, which is transaction executive approval language. And we write our smart contracts in teal, but we also have different wrappers for it. So we have like a Python wrapper for it that you can use. So you'll be basically coding in Python, and that code will be compiled down into teal. So teal is a stack based language. It is Turing complete. uh, it is important to learn that, like teal is like a higher level language. And then it is good to know teal just to debug very certain scenarios. But I think for most of the people who are beginners, it will be good to learn PyTeal, which is a Python-based library to work with smart contracts. I think I'm going to skip this part, otherwise it will go a lot bigger. But if you want to like learn more about comparisons, I think you can also find it online. What is the different comparison between Ethereum and Algorand? You can kind of go through it on the internet. I think I'm going to just go over this very briefly. So dApps, decentralized apps are kind of interacted with wallets. We have different wallets that you can use. We have uh, we have different wallets. One is Algo Signer, which is a browser extension based, something like MetaMask. We have My Algo Wallet, which is a website based wallet, and we also have Wallet Connect, which is a wallet application which is available through different like you can use it on different devices, and so on and so forth. Uh, I think it's going to take a lot of time if we go over this, but let's just quickly go over PyTeal because it's the most important part. So PyTeal is, as I said, is a Python-based language which is used to write smart contracts. And this is a very good flowchart of what PyTeal actually does. So we create PyTeal code in Python, and then when we execute it in the background, it's going to compile PyTeal into Teal, and then Teal will be converted to bytecode, and bytecode is something which is readable by your virtual machine, in case it is AVM, Algorand virtual machine in our case. So it compiles it and it submits the code directly to the node, and it's going to compile it on the blockchain, and then we finally submit the blockchain, and we we go on with creating an app. So this is like a flow chart explaining how it does. So it's very important to understand what is the flow of these things. uh, Another thing that I wanted to mention was PyTeal expressions. They represent AST, which is abstract syntax tree. So basically, PyTeal objects are used to create expressions, and these expressions are combined, called as sequences, which is the whole PyTeal code, and the rest of the flow remains the same. It compiles down to teal, and then bytecode, and then gets submitted on the chain. So moving to the next slide, uh, what are the prerequisites to get started with PyTeal? So you should have basic knowledge of Algorand smart contracts, which you already do by now. I've already gone over what are Algorand smart contracts. You should be comfortable with coding in Python, and you should be familiar with VS Code and how to use terminal for executing different transactions. What is the technical stack that we need to interact with the blockchain with the help of PyTeal? So first is PyTeal. You need to have the library installed on the system that you're working on to interact with the Algorand smart contracts. You'll need the sandbox setup, which we already did. So make sure that your sandbox is set up, make sure the PyTeal is installed, and then you'll be good to go writing the smart contracts. Uh, I mean, I don't have to discuss this particularly, but I think you get the gist of it. What is the difference between Teal and PyTeal? Teal is very assembly-like language, very hard to read, very hard to debug, very hard for a new person to kind of code. But PyTeal is very familiar with the Python developers. Very easy to read, write, and debug, and you can use things which are inherently available for Python, which are like loops and types, which is available with the help of PyTeal. Now, here's a very basic program of Hello World, which is written in PyTeal. Here we use the approval program, which has a sequence, and within the sequence we have the string hello world, and we are just returning it, and we are compiling it. Now there's a lot of things happening here. Let me see if there's another slide which goes, yeah. So next, in this next slide we'll see what compile teal does. But just to tell you guys, pyteal objects create expressions, and they build the abstract syntax tree, which is AST, and then calling compile deal, which is, you can see in the last line, print compile deal approval program. Calling the compile deal method actually compiles the AST into deal, and then the rest of the flow remains the same. And of course you'll need to compile the deal method to run the specific contract. Coming to sequences, sequence SEQ basically stands for sequence of pyteal expressions. We combine multiple expressions and join them in a particular sequence. Its arguments are the expressions to include in the sequence, so either as a variable or arguments, or we can also have it as a list which can be passed through. And compile till, as I said, it expects a pyteal expression to go through it. And next is, what are expressions? Expressions are methods that compile down to teal, and we use compiler for that. And then all the other methods such as log or return also expect pyteal expressions. So we are working with mainly expressions when we are coding in pyteal. Now, very interesting questions come is, like, what are the different types which is available, and how we can kind of change between byte and int. Just a second. So I think uh, Yeah. So we were talking about bytes and ins, right? So it only has two types. Python has only two types, bytes and ints. And we'll be basically putting integers in, wrapping them in int, and now we have Python expressions. So as you can see, I equal to int 5. So it is just wrapped inside of int, and then we have it as an expression. And similarly, I've kind of done it for the other one. We can only use int or byte, so we're using byte for the rest of the ones. And then you can reference these expressions anywhere in your smart contract, and you can pass it on as a string as well if you want. It can be a byte array or base 16. So you can just pass that in, and you will have a constant value to reference in your Python program. Now, to carry out conversions between these two different types, we have something called as I to B, which is to convert integer to byte, and we also have B to I, which is to convert byte to integer back. Again, it is very important to note that all of these conversions are happening in the background, and it is not happening in the real time. When we call the PyTeal expression, it will then compile down to teal, so it's not happening instantaneously. It's gonna happen in the runtime. So it's very important to note that. Now, coming to the math operators, we have different math operators in PyTeal. We have all the basic ones, and mostly all the ones that we need. We have addition, subtraction, multiplication, modulo, etc. We also have and or for Boolean expressions that you can use to build larger expressions. So we also have byte strings that we have concat. We also have concat, which concats two or more byte strings together, and also we have substrings, which lets you pull out a specific section of a byte string to use it. So with the help of substring, you can use a specific section of a byte string. We also have len, which is used to which lets you basically access the length of the particular byte string. And we have a lot of crypto operators as well, which you can probably find it in the documentation. Now, coming to the transaction fields, so it's very important to understand what are the informations that we have access to, and this is where transaction fields come into place. So we have fields from the current transactions, which can be used to do some computations. Now, smart contracts have to be invoked by a specific application, and it's called which is called transaction type. And this transaction you can set field to describe input to your program. So some of these inputs can be like sender of a current transaction, or you can say an array which is associated with one of the accounts of the transaction. You can also get length of the array. You can index them to look at certain elements, and you can also look at similarity between the application arguments, which you can use to extract whatever you need. So I've added the examples for that. So you can use txn.sender, you can use txn.accounts.length to access the length, and then for a particular account, you can use accounts, and then you can use first to get access to the first account, and then all of these different things. Uh, Next, we have inner transactions. Sorry, we have atomic group, atomic transactions. As I said, atomic transactions can wrap up to about 16 transactions at once. So you can bundle different transactions together. We already talked about this. If any of the transaction fails in the complete group, then the whole group fails out. But yeah, it gives the functionality of tying up these different transactions together and let them succeed. Uh, Now the example for that is the one that I've mentioned here. It's called GTXN. So previously we had TXN for normal transactions. For atomic transactions, we have GTXN, and then everything kind of remains the same. Uh, that you can check out more examples for this in documentations. Now, states, I've already gone through this. We have two persistent states, global and local state. Global, you only get one instance, one app. You have limited key value pairs, so it's hard for us to create essentially infinite number of key pairs or have infinite users to use it. I've added examples of how you can kind of use it. You have something called as global put to kind of write the data. You have global get to access the data, and then you have global delete to delete the different data. Similarly, for local states, we have local put, local get, and local delete, which does the same exact thing, but this is scalable for multiple users, not just restricted to 62 key value pairs. Uh, so yeah, coming to control flow, these are special commands that you need to tell the chain uh, uh, that the program is successful or not, or if you can commit these final changes or not. So you have approve or reject, and you can approve the transactions and exit, or if you want to reject the transactions, then you can also reject it and exit. So you have to specifically say if you want to approve a particular transaction which was done and commit to the mainnet or not. Then we have conditional statements such as if. It is similar to what we usually have traditionally. Slightly different because the I is capital here, so it's not a normal if. It's capital IF, but this can be used to express basic conditions that we have usually, like if else, else if, and then if and then, all these different things. And then we have something called as conditional statements, where we have conditions. So you, instead of writing a bunch of if else, you can use this, which is kind of like switch. If any of these is true, then it will be executed. If all of them are false, that it will throw out an error for us. So it's like using a switch. And then we have inner transactions. This is one of the examples of how we can do inner transactions using PyTeal. In this example, you can see we have inner transactions builder to build these inner transactions, and this is what we use to kind of use within in our smart contracts. Now, I'm just going to wrap up the session now. It's already been more than an hour, and I didn't want to like overwhelm you with a lot of information, but there is a lot of information that you can just access with the help of our developer portal and with the help of our documentations. So feel free to scan the page to get access to our Discord. If you have any questions or any doubts, you can always ask questions in the Algorand Discord. And if you have any questions during the hackathon, I think I'll be in the Discord server to answer those. So feel free to pick me over there. But yeah, you can follow all of these places and check out check out our developer portal, check out our Algorand forum to get access to the resources that you need to build further. And about myself, if you want to follow me, you can follow me on Twitter. If you have any questions, I think Twitter is the best place to kind of connect and send me a DM. So you can like follow me, send me a DM if you want to learn about something specific. And if you want if you want to ask any particular questions, if you have like a detailed question, if you want to book a meeting, there is also a meeting link which is attached, so we can also chat and clarify your doubts. And yeah, as I said, I'm doing developer relations for Asia. If you have any questions, related to your development journey on Algorand, feel free to ask me those questions on LinkedIn or Twitter or whatever it is. And that was about the session. I'll just stop sharing my screen now, and I'm just gonna see if anyone has any questions which I can answer.
I think there are a couple of questions on creating the smart contracts, but I think you'd covered them at a later stage.
Yeah, because of course it was covered between different parts. So I hope everything is clear now. But still, if anyone has any questions, feel free to ping me on Twitter or LinkedIn, whatever suits you.
Yep. Um, so we'll be sending you any questions in case there are any, and also you'll be on our Discord server available
Yeah,
to all our participants. So yeah.
yeah.
Firstly, thank you, Pranjal, for the amazing session. It was really amazing to have you here. Uh, Next, on behalf of Innovate IT, I would really like to extend my thanks towards Algorand for the constant support and the humble sponsorship that empowers us to create and conduct events like VinHack. Next, I
Yeah,
would like to thank.
absolutely. I mean, I would like to thank you as well to, get access to so many developers. And, like I'm looking forward to seeing all the different people just building different projects on Algorand. But yeah, I'll let you finish that. Yeah.
Next, I would like to thank you for your presence at this time and taking your time to share such an incredible amount of information and helping out our participants in creating wonderful projects. Um, we have received a lot of projects that are going to be we've received a lot of project ideas that are going to be built on top of Algorand. So yeah, definitely we'll be looking forward to those projects, and hopefully they turn out to be the best.
Yeah.
Also, yeah, I would like to also thank our participants, all the viewers who were there along with us throughout the stream. Yeah, I think that's it from our end, and hack on everyone. That's it.
Thank you, everyone. Cheers. Bye.